Alrighty, let's go ahead and get started. So today, obviously, we're doing our exam 2 review. Our next test, or this test, is going to be on Tuesday. It'll be online like the last one, which means Tuesday morning, the test will be posted on the Canvas. It'll be a PDF file, just like the homework assignments were. Just like the first test, you download it, you work it out. You can either work out all the problems on the test itself or on a separate sheet of paper, doesn't matter to me. Work out all the problems, box your answers, and then of course submit back by the deadline, which is 11:59 p.m. that night. So you have the full day to work on it. Of course, because it's a test day, we won't have class that day. Again, as is usually the case, you can expect about 5 to 7 questions. That's usually a good amount of questions for, a 1-hour test in this class. Definitely have a calculator, just like before. Every question is calculation type, so you actually get answers, you get number answers instead of things like multiple choice or true, false, or anything like that. So you need a calculator so that you can get actual answers. You don't just leave numbers in an equation and expect me to calculate the answer for you. So what are the topics? That's the bulk of what we're going to do today. Well, this is true generally for all my courses. Whenever I have a test, a mid-semester type test, it's usually on whatever the material is since the last test. And so for us, that means it's on fluids, what we covered in fluids. And what we did in fluids was first, primarily, the big equation was Bernoulli. Bernoulli's equation. And Bernoulli's equation says P1 plus 1/2 rho V1 squared. Oops. V1 squared plus rho GH1 is P2 plus 1/2 rho V2 squared plus rho GH2. So if you remember, this equation was basically the equation we would use when we would be analyzing pipe systems. You have a pipe, water's flowing through the pipe or some other fluid. It may not be water, it might be oil or something else. And the pipe can move around, it could change size, things like this. And you're usually asked something like, find the difference in pressure between the beginning and the end of the system. And so you would use this equation. What I usually do is I write it all out. I then look to see in my problem, are there any terms I could just cancel out from the beginning? And the way you can determine that is when you're looking at the problem, if the problem does not have anything about the pipes changing size, then the speed won't change. Whatever the speed of the fluid is at the beginning, it'll be the same as at the end. And if it's the same, then that means you could just cancel out the terms that have the velocity in it. Since they don't change, it's the same number. And if it's on the same number on different sides of the equation, they cancel each other out. Or if the pipe system does not change height. So if the pipe doesn't go up to the second floor, or go down to the basement or something like that, then the height terms won't change. And so they would cancel out. So just to make my life easier, I usually look to see if I could cancel out the terms from the very beginning. If so, great, cancel them out and I leave whatever's left. If not, then okay, I got to keep all the terms. So I just rearrange this equation to solve usually for something like P2 minus P1. Okay, that's whenever the question says calculate the difference in pressure or the change in pressure, that's what it means. Take Bernoulli's equation, rearrange the terms somewhat so that on one side you have P2 minus P1, and on the other side is everything else that's necessary for the question. Then there's a secondary equation we needed whenever we talk about these types of problems, and that is the continuity equation. Now, when I say the continuity equation, I didn't mention this before, but just for your information, since if you're taking this course, then likely you're either getting into physics or engineering in the future. Continuity equation, there's a bunch of different ones in physics. This one we're talking about is the continuity equation for fluids. There's also a continuity equation for electricity, which has to do with the current flow or charges flowing in versus flowing out of a system. Very similar. It basically means something is conserved. That's what the continuity equation does. It conserves something. In this case, what it conserves is the volume flow rate. How much fluid flows per second through your system. Here we're talking about a fluid system, so you're something like you've got some pipes, and I know a gallon of water per second is flowing through the pipe at the beginning. What the continuity equation demands is that if there's a gallon per second coming in, there better be a gallon per second coming out. No matter what you do to the pipes, the way the water flows through the pipes will change such that the amount of water coming in is equal to the amount of water coming out. And the way we write that down is the cross-sectional area of the first part of the pipe times the velocity of the fluid in that part of the pipe. A times V, that is the volume flow rate. If you were to look at the units of what this shows, this would show meters cubed per second. So the volume of water per second. If it's conserved, that means A1V1 must be equal to A2V2. And of course, we know that A, for the type of pipes we're talking about normal cylindrical pipes, is just equal to pi r squared. Okay. So likely in this problem, if we have to keep the terms with velocity, then that's because the pipes change size. So you usually know either the radius of the pipe or the diameter of the pipe. If you know the diameter, of course, what you need is radius to do pi r squared, so you divide it by 2. And you'd need the radius at the beginning, or you may know the velocity, so you don't need to worry about the radius. But usually you have the radius sitting there, so the radius and the velocity at the beginning, and then you'll probably know the radius at the end, since the pipe changed size. And so you could calculate the new velocity V2. So with these two big equations, the class of questions we can answer are all things about pipe systems. Okay. Then from there, we also discussed for a little bit how much pressure an object feels because it goes underwater. This is another area of fluids that becomes important. And that is, as an object is placed inside of a fluid, the fluid has to move out of the way to make room for the object, which is unnatural, of course. So the fluid wants to go back to the way it was, and thus it applies the pressure onto the object. If you go in the water is pushing on you, trying to get to where you are. And so what we have is the pressure depth relationship. And this relationship says that the pressure acting on an object, because it has been submerged in a fluid, is given by what is the density of the fluid we're talking about? Because surely a really thick fluid will cause more pressure than a very, very thin fluid. If you're in air, you feel one pressure. If you're in water, water is more dense, so you feel more pressure in the water than you do in the air. Times G, which is, of course, when you're underwater, there's an amount of water above you being pulled down by gravity. And so that water is like being placed on top of you. You feel the weight of the water pushing down on you. And so it should, of course, depend on the kind of gravity we have here on Earth. If we're on a different planet, then we would have to use the gravity for that planet. And so G comes into play here, 9.8 times H, where H stands for the depth, how deep you go. Obviously, H seems like what it means is height. And usually when we talk about height, we talk about how much higher the object is, the distance upwards. But in this case, when we use H, we mean how low. From the surface, how deep did you go? So that's the depth. And then we realize that, well, wait a second. If we take the extreme case of an example of an object that isn't yet submerged, but is just placed on the surface of a pond, and I ask what's the pressure acting on the object there, we would say the pressure is 0. Because obviously, if we're not submerged under the water yet, our depth is 0. We're at the surface. We haven't gone down yet. But of course, I know that the pressure on an object that's not underneath water is not purely 0. The fact that he's in the atmosphere means it feels some pressure. It's just that it doesn't feel some extra pressure since it's underwater. And so this gives rise to the difference between what's called the gauge pressure and the absolute pressure. And so that's another thing we have to take into account, absolute versus gauge pressure. And here what we find, one way of writing this, is that the absolute pressure felt by an object is the gauge pressure, which acts on the object, plus whatever the natural atmospheric pressure is when there's not some extra pressure. Okay, so what this means is if a scuba diver goes 10 meters under the water, what pressure does the scuba diver feel? Well, the answer to this question depends on exactly what it is you mean. Do you mean all the pressure that's being placed on the diver, or only the amount of pressure more than they normally feel since now they're underwater? Well, the total pressure felt by the diver is what's called the absolute pressure. And that is, the diver always feels atmospheric pressure because it's on Earth and the atmosphere pushes on you. But now he's also underwater, so you have to add in the effect of the water. Gauge pressure, on the other hand, says, look, I get it. The diver feels atmospheric pressure, but everything does. So we could just pretend like the starting point that has atmospheric pressure on it is just 0. Everything feels it. So if everything feels it, it's not a big deal. Just ignore it. All I care about is how much more pressure will he feel since he's underwater. And so that's the difference between gauge and absolute pressure. And again, sometimes you hear absolute, sometimes you hear total pressure. They mean the same thing. The rule you should use for when you give an answer, should I give gauge pressure or absolute? The rule I want you to use is always give gauge pressure unless the question says specifically to give absolute or total pressure. Okay. So if I were to say, what pressure does a scuba diver feel when they go 10 meters under the water? I'm asking for the gauge pressure. So you would just use rho GH. If I said, what's the total pressure felt by a scuba diver who goes 10 meters under the water? Then you do the rho GH, which is gauge pressure, but then you just add on atmospheric pressure, which is just a number, and that number would be given on the test. It's just a constant. And so that's what we learned. That's what we had for fluids. These four relationships, these four equations, basically, are what this test will be on. So you can expect, since there's 5 to 7 questions, you can expect about 2 each. Not exactly, because usually continuity kind of goes along with Bernoulli. It's not like there's just a question about continuity by itself. Generally speaking, if you're doing a continuity thing, it's because you're also talking about Bernoulli. But you can expect something like two questions of each style. Certainly there's going to be pipe systems. Some of those pipe systems you need all the terms for, some of them only some of the terms. And then certainly there's going to be stuff about the gauge pressure versus absolute pressure. An object goes under the water this far, what will they feel? What kind of pressure will they feel? And things like this. So are there any questions about what to expect from the test or anything like that? I think now you've seen my first test, so you know what to expect. The test will be formatted the same way, same look. I think you're comfortable, hopefully you are comfortable with, the language I use and the verbiage and how the questions look. So this test should not be as stressful since you kind of now are used to things. And it's run the same way. And just like before, if you're going through the test and you have any questions about the test, maybe there's a drawing on the test and you can't really tell what the numbers are, or you're confused about what it's asking specifically, don't hesitate to send me an email and ask me, because I'd much rather clarify something for you so you could get the question right than for you to say, well, I don't know what this is, so I'm just going to skip the question. And as I said last time we had a test, the only types of questions I can't answer for you are those types where you're basically asking me to look to see if your answer is right. I can't check your work before you submit the test. But if you say, hey, look, this question, it looks like you're asking about this, but you don't have this piece of information. Am I missing something, or is this the way it's supposed to be? Those types of things where you clarify the question. Maybe you think, how can I solve this problem? You didn't give me the height or whatever. Well, if you need it and I just forgot, then thanks for letting me know, so that now I can let everybody else know that I just forgot to give a piece of information. Or maybe you think you need this piece of information, but you really don't. And so I'd say, well, are you sure you actually need to know that number in order to solve this problem? And so things like that. So Tuesday is the test. Again, it'll be posted in the morning. I'll send an email when it's posted. Download it, work it out, submit it. Submit it as soon as possible, because it always happens. I get people sending me an email after the test is over, the next morning or whatever, saying there was some issue and it didn't let me submit it. Submit it early, because I want to hear these, if there's a problem, I want to know about it before the deadline, so that I can, there's no fishiness about why you're turning in your test late or something like that. So don't wait till the very, very last minute to turn it in case there is a legitimate issue. And definitely ask me questions if you need to. The only big rule I give for my tests is to do these tests yourself. Work it out yourself, even if you feel you don't know the information that well, you're afraid you're going to do poorly or something like that. Don't worry about it. I'd much rather, and I'd go a lot easier on somebody in terms of their grades if I see that they're legitimately working these things themselves and they're just getting them wrong, rather than someone who's obviously cheating. And you can tell that, they're not doing the work themselves. So work it out yourself. Don't try to get the answers from someone else. Feel free to use all the resources at your disposal. We've got the stuff posted on Canvas, the previous lectures. You've got the stuff we've been doing in class, the notes where I work out a bunch of examples, practice problems, solutions, all that stuff. You're free to use it. So feel free to use that stuff. But the only thing I ask is that you do the test yourself. But anyway, that's all I really have for you today. So unless you have any questions, you're more than welcome to go and eventually enjoy your weekend. And I will email again on Tuesday when the test is posted.
It's the Tuesday after spring break, right?
As next week spring break?
Yes.
Yeah, then it'll have to be after. If we have off next week, then obviously I can't give a test next week. So it would have to be after. I'll double check and I'll send an email about it. But yeah, if we're off next week, like Tuesday, we actually have off, then yeah, it'll be the following. That's right. Thanks for letting me know.
Thank
Any other questions before we go? All right. Well, enjoy the rest of your day.